Alrighty, welcome to this episode of Lectures with Liddington. Today we are going to talk about enzymes. Remember when we talked about proteins, we said one of their jobs was to help speed up reactions? Well, that's where enzymes come into play. Enzymes are a special category of proteins, and their job is to speed up chemical reactions. So inside of your body, there's constantly stuff going on, lots of different reactions. You're making molecules, you're breaking molecules, you're doing both things all throughout your body. And in order to do that in a quick and efficient way, we use enzymes. What enzymes do for us is they lower what's called the activation energy. The activation energy, this is the energy that you need in order to start a reaction. So if you're looking at this chart over here on the side, this blue represents the activation energy without an enzyme. That's how hard it would be. That's how much energy you'd have to put into a reaction in order to actually get it to go. So say we're making, I don't know, maltose. If you want to make maltose, it takes this much energy for that to happen. Well, in the presence of an enzyme, in this case, it would be maltase. Right, see here, ACE means that we're looking at an enzyme. Say it's maltase. It only takes this much energy to actually get that reaction to occur. So they make it just easier for that reaction to occur. With enzymes, they are incredibly specific. One enzyme only has one substrate. I'll tell you what that is, only has one thing that binds to it, only one component that it helps react. In this case, with enzymes, you're going to see ACE at the end of it. So maltase is going to be doing something with maltose. So in the reaction I was telling you about was making maltose. So maltase making maltose, right? That's your enzyme. It's helping that reaction occur. So some other vocabulary here around enzymes. They make what's called an enzyme substrate complex. Substrate, this is Liddington. What does that mean? Well, the substrate is the stuff that binds inside the enzyme. The substrate is the stuff. Maybe that S word will help. But, so if this is our enzyme here, the blue part, the yellow is the substrate. That's the thing that binds to the enzyme, and the enzyme's going to make that react, whatever it is. Maybe it's going to take those two pieces and put them together. Maybe that's the reaction. Maybe it's going to take that piece and break it apart. Either way, whichever direction it's going, it's so specified to just this yellow substrate here, that's the only thing that's going to fit. The place where it fits is called the active site. So see these grooves here? That's called the active site. That's where the stuff that the enzyme is helping catalyze, it is actually going to go in what's called the active site. Now, an example of this in action would be, say, lactase, right? So lactose, we talked about being a disaccharide. It is two simple sugars, two monosaccharides bound together, and our body needs to break those two pieces apart. So if our substrate is lactose, the enzyme for that is incredibly specific, and its job is to break that disaccharide into two pieces. The enzyme that does that is lactase. So somebody who's lactose intolerant may either not have enough lactase or it may just not function properly. So it's very specific. It's just like a lock in a key. Only this specific key is able to fit into this specific lock. The key is just like the substrate and the lock is just like the enzyme. Real world, lactose is the only complex, the only substrate that will fit into lactase. It is very, very specific. The thing that's really cool about enzymes is they don't expire, they don't run out. We can keep using them. They don't get used up in the reaction. So we have here is our enzyme. Carbon dioxide and water go into the enzyme. They are the substrates. And then the enzyme will put those together to make carbonic acid. The carbonic acid is released, and then now we have an enzyme that we can use again. So it's really nice that we have the ability with an enzyme to just continue to use it. So it's really effective in being able to help catalyze or speed up reactions in our bodies. So let's take a second and practice.